The genetic testing, PGTA, allows us to screen out those embryos having an abnormal number of chromosomes because that embryo can look beautiful in a petri dish, grade AA, but yet be missing a chromosome or having an extra chromosome, preventing it from resulting in a healthy live birth. So today we can identify the safest embryos to transfer, those with the highest pregnancy potential and a lower miscarriage risk.
Yeah.
So that's been a tremendous advancement. And we no longer do fresh embryo transfers. We do all frozen transfers because when we used to do a fresh embryo transfer, we were putting that embryo back into the uterus coming off a stimulated ovarian cycle. So the hormone levels were not natural. They were elevated significantly. Yeah. And that we found after years that it shifted the window of receptivity of the uterus. So the uterine lining wasn't as receptive to that embryo. So maybe those embryos weren't attaching, not because there was a problem with the embryos, but because the uterine lining wasn't as receptive as it could be.
Right. And remember when you attended my live seed workshop and I was talking about the inflammation post-retrieval. Remember, I was giving food suggestions for reducing the bloating and talking about acupuncture and how important it was right after the retrieval, like a day later, to get the extra water out and bring down inflammatory proteins. And you said, oh, that's right, because we are really poking away at the ovaries. And so keeping the conversation open to all these different ideas being exchanged has really morphed the medicine to change that percentage of the success rate, right? All the different...
Absolutely. And, we used to, as you mentioned, put in 3, 4, 5 embryos because we didn't know which ones were normal, which ones had the potential to implant. So the genetic screening enables us to identify, yes, this one has the potential. We can't guarantee it, but it has significantly higher potential than that embryo right next door to it.
Right.
So we can avoid the risk of a multiple birth twin pregnancy.
I can't tell you how many sets of triplets have come through the women who did the seed program prior to the freeze-all.
Oh, really?
Because we were improving the quality of the embryos, and then they were just putting in 3, 4, 5 blastocysts. And I have a couple of those.
Yeah,
and
now we're mostly single embryo transfer just because we are able to achieve a high pregnancy rate, but we can avoid the complications of a twin pregnancy.
Yeah, I think what we should say here is it's that time spent optimizing to, as much as possible, create the normal genetics, healthy outcome, right? Like all of the do it quick things. Maybe what I'm trying to say is having the patience while you're optimizing, because we used to be able to do 8 or 10 IVFs. Back in the day, the woman would get her period, she would be stimulated, the eggs would be retrieved, would put them back in, and if it didn't work, okay, she's on her period, stimulate the eggs, retrieve the eggs. Now there's a lot more of this testing, scrutinizing, using the technology, but the idea is optimal conditions are being created.
Optimal conditions, for the embryo to be the uterus, even in the IVF laboratory, just the conditions have changed that developments have allowed us to keep the embryos alive longer, from 3-day culture to a 6-day culture. And today, 60, sometimes 70% of the fertilized eggs will develop into a blastocyst, which is the developmental stage an embryo must reach if it's going to have a chance to implant. So 25 years ago, we couldn't keep embryos alive that long to enable us to do what we can do today. But due to changes in the culture media, the laboratory environment, we are able to keep the embryos alive longer.
Yeah.
So lots of advancements.
Oh, yeah. That email I was telling you about earlier, the this woman I heard from recently let me know that her day 7 blastocyst, it was the fourth of her 4 normal embryos, or no, they were untested embryos, and this was the one that was on day 7, and she said in the email that she was not even going to implant it. But something that she picked up on in the seed movies made her think, why not? I should just try it. And now she has a 2.5-year-old little girl.
Beautiful. Beautiful.
Yeah. I mean, those day 7 embryos, they still have.
Well, we know they have lower pregnancy rates than day 5, day 6, but we have live births from day 7 embryos.
Just
So,
like the low level mosaics. That's something we could talk about too.
right, when we do the genetic testing, it ideally tells us either normal, abnormal, but sometimes we get something in between. So when the embryologists biopsy an embryo for genetic testing, they're removing 3 to 6 cells from the outer layer of this 100+ cell embryo, and these are the future placental cells. We're not touching the future fetal cells. And then they'll test those cells in the genetics lab, and if more than 80% is read as normal, it's a normal embryo. If more than 80% of the cells are abnormal, it's an abnormal embryo. Well, what if it's in between? 40, 50% are abnormal. That's called a mosaic embryo. And so what that means is either that the embryo has a mixture of normal and abnormal cells, or it could be that the fetal tissue is entirely normal, but we happen to biopsy a future placental cell that had an abnormality. Because the placenta is this mass of rapidly dividing cells, and you can occasionally have an aberration, and that abnormal cell could die off or be corrected.